Hey everyone, welcome back to another video. Today I'm going to be showing you how to make a complex of nickel and triphenylphosphine. Let's get to it. There are two ways we can go about this. We can make the nickel-triphenylphosphine chloride complex, which is a green-blue solid, or we can make the, or at least in my opinion, more interesting thiocyanate or rhodonide salt by reaction of triphenylphosphine, nickel chloride, or any nickel salt for that matter, with a thiocyanate salt in anhydrous alcohol. So I think that's probably what I'm going to do first, is the thiocyanate salt. It's a really nice brick red color. I'd like to give a special thank you to all the guys on the Discord for giving me this idea and giving me access to the synthesis. So first off, we're going to need 2.82 grams of triphenylphosphine. This is double of what the original synthesis said, which was 1.41 grams, so I'm just doubling that. I got this triphenylphosphine off of eBay. It's actually a lot harder to find than you might think, and a lot more expensive than you might think. This stuff's almost $1 a gram, so I could only really buy about 25 grams. And it comes in this really cool bottle. It's pretty nice. Alright, so let's weigh out 2.82 grams of triphenylphosphine. And here we have the 2.82 grams of triphenylphosphine. What I'm going to do now is go ahead and add it to our sort of flask reflux setup that I've got set up off camera. As far as apparatus goes, I have a normal reflux setup with a two-necked 250 milliliter round bottom flask with a, I actually don't really remember the name of this condenser, but I just sort of picked it out of the couple ones I do have. So this one should work fine. I've also got a pump with some water. I'm going to add some ice in there because we don't want a bunch of anhydrous alcohol vapors going everywhere. Next, I'm going to add 30 milliliters of 99% anhydrous isopropyl alcohol. Go ahead and put a stopper on that for right now. Next, we're going to need 1.2 grams of potassium thiocyanate, or potassium rhodonide, however you like to call it. So I'm just going to go ahead and weigh that out. As we can see, it's a sort of wet-looking. Ooh, that's way too much, actually. Yikes.
What kind of shit is that?
Let me go ahead and adjust that, and I'll come right back. Okay, now that we have the 1.2 grams of potassium rhodonide, we can go ahead and add that to a further 30 milliliters of anhydrous isopropanol. I don't have any anhydrous ethanol, which is what the procedure calls for, and also I don't have any sodium rhodonide or sodium thiocyanate, which is also what the procedure calls for. I found sodium thiocyanates a bit too hard to find and a bit too expensive compared to the potassium thiocyanate. So we're going to go ahead and add this to the 30 or so milliliters of anhydrous alcohol we have, and then we're going to go ahead and continue on with adding a certain metal salt. Alrighty. Stirring is on, and in goes the salt. And that should take a few minutes to dissolve. If it doesn't, it's perfectly alright to warm it up a little bit. And finally, we're going to need 1.84 grams of nickel-2 chloride. Now, I just made my nickel-2 chloride by reacting nickel carbonate and hydrochloric acid, then evaporating the solution until I got a nice light green powder. And here's the nickel-2 chloride, 1.84 grams of it. We can go ahead and add this to the thiocyanate and alcohol mixture, and then we can go ahead and warm it up until it dissolves and there's a white solid produced, which is the reaction of the nickel-2 chloride and the potassium thiocyanate forming potassium chloride, which precipitates out, being the white solid, and leaving behind a blue solution of nickel thiocyanate. Let's get to that. Alright, now that the nickel salt is all in, oh, hang on, someone's just stuck on the sides. Go ahead and warm this up until a white solid is produced and we have a relatively blue solution. I might add some more alcohol because it doesn't look like things are dissolving too well at the moment. Okay, now that everything's going along just fine in our beaker on the hot plate, we can go ahead and start to turn up the heat to get this triphenylphosphine to dissolve in this alcohol. And I'm also going to plug in my condenser pump. I'll come back when there's some sort of update. Update! Okay, so I'd say we're pretty much done. We've got a sort of yellowish mixture left, and all the triphenylphosphine has, for the most part, dissolved. And actually, now that I look at it, it has all dissolved. And we are getting a nice little slow reflux of the alcohol. So what we can do now is go ahead and stop this. It's pretty warm by this point now. And we can go ahead and filter it. We should get a fairly bluish colored solution. Or rather, it looks like it's going to be a sort of greenish. Actually, no, it's more of a blue, I guess. But this is about what we want. It says in the literature aqua blue, but you know, this will have to do, I guess. It's good enough, and we're sort of left with a slightly yellow precipitate in both the filter and the beaker. So when we're done with this, we can go ahead and add it to the triphenylphosphine and see what goes on. Okay, now that we have our solution of nickel-2-thiocyanate in anhydrous isopropanol, we can go ahead and pan back over to the triphenylphosphine in the flask, which is refluxing nicely in triphenylphosphine in alcohol. So what we have to do next is add it, although the literature says through the condenser, but I think it would be better just to add it through the second arm over there, because if I were to add it through the condenser, then I would need to you know, wash it, like follow it up with like a chaser of hot isopropanol. So I'm not going to do that. I'm just going to add it straight to this solution of triphenylphosphine in isopropanol. And what we should get is a reddish, brownish color of the complex forming. So let's go ahead and do that. Alright, here we go. And this is the formation of the complex. Hey, look at that! We've got lots of solid precipitating out. That's a very good sign. Now, I chose this reaction due to the sort of unique nature, I guess you could say, of the nickel to salt. I don't know of any nickel compounds that are red. I mean, if you know of any nickel compounds that are red, please let me know in the comments below. So anyway, what we have to do now is reflux for a further 7 minutes and then cool this for 5 minutes. So I'll come back when 7 minutes is up. Alrighty, bud. So 7 minutes has been up. Actually, it's 8. So went on a little longer than you know, I'd like, but or at least what was called for. So now we just got to let it cool, and then we can go and filter it. Now we just have to filter it. Now I'm going to go ahead and wash with a small amount of cold isopropanol. Then it can be dried in a room temperature, dark place. Or if you have it, use a desiccator. Now let's get on to the next complex. Okay, so now we're on to part 2, which is making the nickel-to-dichloride triphenylphosphine complex. So what we're going to need here is I have 1.4 grams of triphenylphosphine in 20 cc's or 20 milliliters of anhydrous isopropanol. And if we turn over here, I have 0.6 grams of just nickel-to-chloride semihydrate, and about 20 cc's or 20 milliliters of anhydrous isopropanol. And I'm going to heat this until I get a relatively yellow-green solution, and then we're just going to add it to the triphenylphosphine, which is refluxing in isopropanol. And hopefully we should get the dichloride nickel to triphenylphosphine complex, which it should be a bluish green solid. Meanwhile, the nickel triphenylphosphine thiocyanate complex is filtering nicely. It's a little more red than it appears on the camera. It appears, most colors on my camera appear a little more washed out than they are in real life. So this one's more of a vibrant brick red orange color than sort of muddy brownish clay color that you see right now. Okay, now that we have the nickel to chloride in anhydrous isopropanol solution, starting the filter, we can go ahead and get ready to add it to our triphenylphosphine in isopropanol mixture. So when it's done filtering, I will go ahead and add it through the sidearm. After it's added, we're going to go ahead and reflux it further for 6 minutes and then allow it to cool for 4 minutes. And then we can go ahead and filter. Alrighty, that should be about good. So what we can do now is add it to the triphenylphosphine solution. I keep forgetting to say that. Regardless, we should get a green/blue, very dark precipitate of the nickel to chloride triphenylphosphine complex. Alright, let's get to it. I'm going to add this solution to the sidearm, and let's see this color change in this nice complex. Here we go. Beautiful. Huh, it's weird. It has sort of different colors. Looks sort of reddish on the camera. It's more of a green-yellow, but I don't see too much of a precipitate. Hopefully that'll change. Here's what we are left with after filtering. We are left with a very dark, very interesting looking, sort of bluish black powder. The camera actually picks up the blues better than I can see them. But yeah, this was a really interesting one, especially with the all the colors involved. So, this was a video on 2 complexes of nickel and triphenylphosphine, one being nickel to triphenylphosphine thiocyanate, the other being nickel to chloride triphenylphosphine. I really hope you enjoyed. This was a very fun and unique, interesting experiment for me to do. If you enjoyed this video, you can go ahead and rate it and subscribe if you want to. Thank you so much for watching, and I'll catch you guys next time.